This project represents a temperature-controlled fan speed and motor RPM readout circuit. It used several components to try to take in the analog data from both the motor and the temp sensor. We used a simple analog temperature sensor, several op-amps. We had a motor where we constructed a half-disc fan and then a photo sensor. One of the central pieces was the LM2907, which converts frequency to voltage, and that would give us our RPM readout. And then for redundancy, we used another op-amp in a voltage follower setup to read that into current, 1 milliamp per 1000 RPMs. This is actually the way a lot of old tachometers worked, simply converting frequency to voltage to get a readout on your dashboard. The whole premise of this system was modeling something like you might find in your home PC, where there is a temperature monitor, checking out the components. If things start to overheat, they would kick on a cooling fan. That fan could be adjusted for speed with its output values, which we were reading in both voltage and current. And you could speed or slow down the fan, turn it off, depending on the cooling necessary. So this circuit is actually pretty similar to the circuit I had for my digital electronics final. It's representing a motor fan speed controller with a temperature reference. You have a little TMP36 or an LM36 here. We're using the potentiometer to set the reference. The two are paired with this LM324, which is 4 op-amps doing different functions throughout the circuit. The first pair is using the temperature probe with the potentiometer in conjunction with this MOSFET here as a switch to run this motor. I've got this little homemade cardboard mount here and this half disc cardboard plate that's running through the photo sensor here. This has a little infrared photo-transistor. There's an LED in there. The LED emits light, and when the disc is not covering the sensor, it turns the transistor on and you get a voltage spike, which goes to this frequency to voltage converter, the LM2907. Here through our oscilloscope, you can see what the LM2907 is getting as its input. As we increase the speed of the motor, we see the pulses increase in frequency or decrease in frequency as we slow the motor down. That basically puts out a voltage, which we can measure here. That is a known voltage for every 1,000 RPMs. And then we rig up one of the last op-amps, which is going to be running through an ammeter. I've got my multimeter set for amps right now. So we can power on the motor and we can power on the circuit. As I set the reference point above or below room temp, we should see the motor turn on. So there we go. But we see the motor going on. As we speed up or slow down the motor, we should see the amps change. And this is in milliamps right now. Slow it down. And then again, we have the tandem temperature pair here of the potentiometer with the reference, which is like your home thermostat, and this little temperature probe, which puts out a certain millivolt signal for every degree Celsius. And again, if we change the reference, we'll have it go on.